Hey, welcome back. This is 10.3, the last section in college algebra, geometric sequences and series. So a geometric sequence is just another type of particular sequence. This one is built by, well, let me see if you can guess. So our first term is, let's say, 2, and then 10, and then 50, and then what's our next term? 250, right? So what am I doing each time? This time, I'm multiplying by 5. And that number we're multiplying by is going to be called the common ratio this time instead of the common difference. Let's go ahead and give this a definition for the geometric sequence. A sub n will be equal to a sub, this is the recursive definition, by the way. Again, we're going to have to build our general nth term formula, and then we'll worry about the sums of these sequences as well. Okay, so recursive definition first. So a sub n is equal to a sub n minus 1 times r, where r is the common difference. Oh, sorry, common ratio. Okay. So you get to the next term just by multiplying the previous term by some number. And that number could be, anything you want. So let's take a look at building some of these. So they give us a sub 1 is 5 and r is 3. Okay, so you start with 5, multiply by 3, 15, multiply by 3, 45, multiply by 3, 135. Okay, if you're sort of iterating this out and just looking at what's happening, what do we have? We have 5. A sub 2 is 5 times 5. A sub 3, oh sorry, 5 times 3. Sorry. A sub 3 is 5 times 3 times another 3. And what I'm doing is kind of suggesting a formula. A sub 4 is 5 times 3 squared times another 3. Okay, so you can kind of guess now what our nth term formula is going to be. For example, what is a sub 10? That's going to be 5 times 3 to the 9th, right? So what I'm thinking is our nth term formula, a sub n, will be a sub 1 times r to the n minus 1. Okay. Okay, let's not get too far ahead of ourselves. Let's go number 4. A sub 1 is 24, and our ratio is 1/3. So a sub 4 is 24. Sorry, a sub 1 is 24. A sub 2 is 24 times 1/3, which is 8. A sub 3 will be 8 over 3. A sub 4 will be 8 over 9. Sorry, I'm looking at my notes. I have something funny there. Okay. And, okay, so I think so if you were to iterate these out again, so a sub 1 is 24, then a sub 2 is 24 times 1/3. Okay. A sub 3 would be 24 times 1/3 times another 1/3, which would be 1/3 squared. A sub 4 will be 24 times 1/3 squared times another 1/3, which would be 1/3 cubed. And then, like a sub 20. What's a sub 20? Well, that'll be 24 times 1/3 to the 19th. It's always just a sub 1. So, in general, a sub n will be a sub 1 times 1/3 to the n minus 1. So that leads to our general formula. Okay, so our general term formula for these geometric sequences is going to be a sub n equals r. Oh, sorry, a sub 1. A sub 1 times r to the n minus 1. Okay. Okay, so now we want to play around with this new formula. So first problem, find the general term formula, and then find a particular value, like a sub 12 or something. Okay. So number 12, yeah, find a sub n and a sub 12. They're given at a sub 1 is 4 and r is negative 2. Okay. So a sub n, of course, will be 4 times negative 2 to the n minus 1. And then, of course, a sub 12, you just plug in 12 for n. 4 to the negative 2 to the 12 minus 1 is 11. And if you put that in your calculator, you'll get negative 8192. Next problem, they give you some terms of the sequence, 1.5, negative 3, 6, negative 12. And they want the nth term formula. So find a sub n and a sub 7. Okay. So a sub n will be a sub 1, 1.5, times the common ratio to the n minus 1. To find the common ratio, you just take two consecutive values and divide them. So r is always going to be a sub n all over a sub n minus 1, which in this case, if you use a sub 2 and a sub 1, it will be negative 3 all over 1.5. You could also use 6 and negative 3, though. You can use any two terms that are consecutive. You end up with negative 2. Okay, so r is negative 2. There's our formula. And then a sub 7 will be 1.5 times negative 2 to the 6. Put that in your calculator, you'll get 96. Okay. 24, 0.0007, negative 0.007, 0.07, etc. Let's get the common ratio first, right? So r is going to be, let me take these two terms, 0.07 all over negative 0.007. So what is that? The guy up top is 7 100ths. The guy in the bottom is negative 7 10s, 100s, 1000s. So if you rewrite that, it'd be 7 100ths times 1000 sevenths, negative. Sevens cancel, 2 of the zeros cancel, and you're just left with negative 10. Okay, so a sub n will be a sub 1, 0.0007 times negative 10 to the n minus 1. They also want us to find a sub 7. So 0.0007 times negative 10 to the 6. You plug that in your calculator, you'll get 700. Okay, so again, we want the sum of a formula for the sum of the first n terms of a geometric sequence. Okay. So here we go, 2, 3, sum of first n terms of geometric sequence. And again, there's kind of a trick to figuring out the formula. You kind of, in this case, what we're going to do is take s sub n, which will be, if you just look at the terms of an arithmetic sequence kind of written generally, it'll be a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus all the way up to plus a sub 1 times r to the n minus 1. And then what we're going to do is this clever trick of subtracting r times s sub n. Okay? So r times s sub n, you're just taking s sub n and multiplying everything by r. So instead of a sub 1, you'll have a sub 1r. And we're going to realign them. Okay? So if I multiply s sub n by r, I get, first off, a sub 1r. If I multiply a sub 1r by r, I get a sub 1r squared. If I multiply a sub 1 r to the n minus 1 by r, I'll do that up to the top right corner here, a sub 1 r to the n minus 1 times r, well, that's really r to the 1, right? And then these are like bases, so you can add their exponents. So it'll be a sub 1 times r to the n minus 1 plus 1, which is a sub 1 r to the n. Okay, so this last term will be a sub 1 r to the n. Okay. And then we could subtract. So on the left, you'll have s sub n minus r s sub n. On the right, you have this huge cancellation. All this junk cancels, and you're just left with a sub 1 minus a sub 1 r to the n. Okay. For our formula, then we're going to try to solve for s sub n, right? So we factor out an s sub n. You end up with 1 minus r. On the right-hand side, I'm going to also factor out an a sub 1. 1 minus r to the n. And then divide both sides by 1 minus r. So you'll have s sub n equals a sub 1 times 1 minus r to the n all over 1 minus r. And that's our formula for the first n terms of a geometric sequence. Okay, so let's try it. Here's 27. Find the sum of the first 11 terms of 3, negative 6, 12, negative 24, etc. Okay. So I need the A1 value. I got that as 3. And then I need the R value. Okay. They want the first 11 terms, so n is going to be 11. Anyways, R is going to be the ratio of two consecutive terms. It's negative 2. And then we just plug it into our formula. So S sub 11 will be 3 times 1 minus negative 2 to the 11th, all over 1 minus negative 2. Okay. Then if you plug that in your calculator, and I suggest you do that to make sure you get the right answer, because there's a lot of like negatives and exponents floating around in weird places, you should get 2049. Okay. Okay, let's look at another one. So this one has some summation notation, 35. We have the sum from I equals 1 to 6 of 1/2 to the I plus 1. Okay. So what I'm going to do is expand it a little bit. I equals 1, you'll have 1/2 to the 2. And then I equals 2, you'll have 1/2 to the I equals 2 is 3, plus all the way up to 1/2 to the 7th. Okay. So the R value you can find just by taking two consecutive terms and looking at the ratio. So 1/2 cubed all over 1/2 squared. Those have like bases, so you can subtract their exponents. And the common ratio is just 1/2. Then a sub 1 is 1/2 squared, which is 1/4. Okay. And then our formula, we want the first apparently 6 terms, right? So from 1 to 6, that's 6 of them. S sub 6 will be a sub 1, which was 3, times 1 minus 1/4 to the 6th power, all over 1 minus 1/4. One minus, sorry, it's our R value is 1/2. I was using the A value. Oops. So these are both 1/2. Okay, and then you got to put that in your calculator and evaluate it. Don't even really need a calculator for this one. It'll be 1 minus 1 over 64, all over 1/2. So that'll be 3 times 63 64ths times the reciprocal of 1/2, which is 2, which equals, I guess, did I screw that up? Seems like I did. Oh man, did I put... Sorry, I must have screwed something up. I screwed up the formula. It should be a sub 1, and a sub 1 is 1/4. So sorry. Butchered that. That's 1/4 right there. That's 1/4. On the test, I'll give you this formula if we need it. So that would be 1/2 times 63 64ths. So 63 over 128-ish. Okay, let's look at one application, and then we'll go on, or one or two applications apparently, and then we'll go on to our next issue. I need my book so I know what the problem says. This will be on page 1074 if you're interested in opening your book like I am. 1074. Okay. 7574. So look at some apps. And basically this is about salary again. So problem 67. A professional baseball player signs a contract with a beginning salary of $3 million for the first year, and then an annual increase of 4% per year beginning in the second year. That is, beginning in the year 2, the athlete's salary will be 1.04 times what it was in the previous year. What is the athlete's salary for year 7 of the contract? Okay, so this is a geometric type sequence. The first term is $3 million. The common ratio is then 1.04. And then they want to know a sub 7. Okay, so clearly a sub 7 from our formula, remember a sub n equals a sub 1 times r to the n minus 1. It's just 3 million times 1.04 to the 6. So in year 7, if you put that in your calculator, the baseball player will get $3,795,957.06. Okay. Must be nice. 73 on page 1075. 73. A job pays a salary of $24,000 for the first year. During the next 19 years, the salary increases by 5%, which means basically our R value will be 1.05. Okay. What is the total lifetime salary over 20 years? Round to the nearest dollar. So this time they said a sub 1 is 24,000. You have an increase of 5% each year. So why is it 1.05? It's because you'll begin with 24,000, and then the next year it'll be 24,000 plus 0.05 times 24,000. Okay, but if you factor out the 24,000, you'll have 1 plus 0.05, so you'll have 24,000 times 1.05. Okay, that's why the R value here is 1.05, and the same for the previous question. The R value is 1.04. Okay. Okay, so anyways, we need our S formula. Let me write out my formula again because I screwed it up last time. Should be a sub 1 times 1 minus r to the n minus 1 all over 1 minus r. I'm 100% sure that's right. No, it's just to the n. I apologize. Okay, so what do we need? What's the total lifetime salary over 20 years? So we need S sub 20. So S sub 20 will equal 24,000 times 1 minus 1.05 to the 20th all over 1 minus 1.05. And if you put that in your calculator, it's just a plug and chug. You get $79,793,582.90, or raised to the nearest dollar, $793,583 if you wish. Okay. Believe it or not, in special circumstances, you can add these up infinitely, an infinite number of terms. believe it or not. So the idea is kind of like if you're adding 1 plus, or maybe 1/2 plus 1/4 plus 1/8 plus 1/16 plus forever, that will equal something. Okay, that equals a number. Basically, you think of it in terms like a box. Here's a square box. First, I fill up half of it. Then I fill up another 1/4 of it. So that'll be this amount here. Then I fill up another 1/8 of it. That'll be like that amount there. And then I fill up a 1/16 of it. That'll be that amount. And then 1/32 of it, etc. You'll never go outside the box. So it turns out that in special cases, when the R value, in particular, we'll want R to be in between -1 and 1. When that's true, you can add up an infinite number of these terms, and it'll equal something. Okay, so it's called a geometric series, and it has all kinds of applications later on for evaluating weird functions like logarithms. Okay, you can figure out what a logarithm equals by using a geometric series. For example, the ln of 3. What the heck do you think that equals? I don't know. How does a calculator figure that out? You can use geometric series eventually. Okay, so it's a long process to get there. You need to take Calc 1 and then Calc 2, and then you kind of have it. But we can give you a feel for it right now. So a geometric series, it goes to infinity. Okay, so up in the upper index, you put the infinity symbol. And then inside the formula, the ith term formula of the sum is AR to the I minus 1. So that'll be A sub 1 plus A sub 1 R to the first plus A sub 1 R squared, on and on forever. Okay. So if you look at the nth term formula for the sum, so the sum of the first n terms will be A sub 1 times 1 minus R to the n all over 1 minus R. If you let n go to infinity, R to the n will go to 0 when R is in between -1 and 1. Okay, so what does that mean? You kind of, if you think of it back in terms of when we were dealing with functions of real numbers, saying something like x goes to infinity as b to the x. X going to infinity causes b to x go to 0. B to the x is an exponential function, right? So as x goes to infinity, if the base b is in between 1 and -1, you kind of, well, in particular, if it's less than 1 but greater than 0, you get the exponential decay. So as x goes to infinity, b to the x goes to 0. And that's kind of the same thing I'm saying, but with n's instead of x's, and an r instead of b. Okay. So if you want to figure out the infinite sum, so I would never use this notation, but s sub infinity, what you do is just let the n go to infinity, but what you end up with is a sub 1 times 1 minus 0, because that r to the infinity will end up being just really, really close to 0 to the point where it doesn't even matter anymore, all over 1 minus r. In other words, s sub infinity is just equal to a sub 1 over 1 minus r. Okay. Okay, so going back to my example with the boxes, if I wanted to add that up, it's a sub 1, which is 1/2, all over 1 minus r. So the common ratio, if you take two terms and divide them, you'll have 1/4 times 2 over 1, which is 1/2. So 1/2 all over 1 minus 1/2 equals 1/2 over 1/2, which of course is 1, which is the area of this box, if you have 1 by 1 sides 1 by 1. Okay. Okay. So right, let's look at some problems where forcing you to do this. And like I said, it doesn't always work, right? So if you were adding up something where the R value was like 1.04, it's not going to equal something over an infinite amount of time. It'll just go to infinity. They call it divergent versus convergent. So when you can go to infinity like this and get an answer, it's called a convergent sum. Okay. Okay. Anyways, let's look at 37. We have 1 plus 1/3 plus 1/9 plus forever and ever. Okay. So a sub 1, we need that. That's 1. We need r. So that'll be the ratio of 2 consecutive terms. It's just 1/3. So this will equal 1 all over 1 minus 1/3, which is equal to 1 all over 2/3, which is equal to 3/2. Okay. Simple enough. Let's look at 43. So here I have the sum from I equals 1 to infinity. I like using little bow ties for infinity. Of 8 times negative 0.3 to the I minus 1. Okay. For this, what I do is usually just write out a couple terms. So I have 8 times negative 0.3 to the 1 minus 1 is 0, so that's just 8, plus 8 times negative 0.3 to the 2 minus 1, which is 1, plus on and on for infinity. So I can see a sub 1 is 8, and then the r value, if you take a ratio of 2 consecutive terms, you just get negative 0.3, and then I could use my formula. So this will equal 8 all over 1 minus, you got to be a little careful with the signs here. It's negative, negative, so it'll end up being a plus 0.3 in the bottom. Okay, so 8 all over 13 tenths, which will equal 80 thirteenths. Okay. Let's look at one more. So one cool thing about these is you can use them to figure out what is something like 0.47 repeating. Okay. So 0.47 repeating is a geometric sum of a geometric sequence, believe it or not. Because you could rewrite 0.47, which is 0.47, 47, 47, 47, etc., as 0.47 plus 0.0047 plus 0.000047 forever. So our a sub 1 is 0.47. Our r value, the ratio, 0.0047 divided by 0.47, which is 47 over 10,000 divided by 47 over 10 hundredths, 47 hundredths. And then simplifying, we'll end up with 100 over 10,000. Cancel out 2 of the zeros, you get 1/100th for the common ratio. So this should equal a sub 1, 0.47, all over 1 minus 1 over 100, which is 0.47 all over 100 100ths minus 1 100ths is 99 100ths. 0.47 is 47 100ths over 99 100ths. And then if you multiply by the reciprocal, you get 47 99ths, which you put into your calculator, you'll get 0.47 repeating. You may notice there's some weirdness going on here, like with the box. This is saying that the sum equals 1, but the truth is you're never really going to fill that box, right? Well, it's kind of a weirdness of forcing arithmetic to mirror reality, okay? Because in reality, you know you can walk across the room and touch the wall, but in the math universe, in order to walk across the room and touch the wall, you first need to go half the distance, then half of half that distance, then half of half that distance. And it's almost like you'll never get there. Okay, so in order to force arithmetic into the realm of the real world, we just kind of assume that, okay, after a while, it's actually going to equal, you know, you'll get to the wall, so to speak. Okay. So there's going to be weird phenomena occurring. For example, 0.9 repeating. Okay, what is that? Well, that's 0.9 plus 0.09 plus 0.009 plus da da da, which is equal to, well, we could figure that out, right? So this is a sub 1 is 9/10, and then our value is 0.09 all over 0.9. Okay, so that's 9/100ths divided by 9/10, which will end up being 1 over 10. So our sum will be 9/10 divided by 1 minus 1/10, which is equal to 9/10 divided by 9/10, and there's the punchline. 0.9 repeating is actually 1. Okay, it's literally so close that we might as well just say it's equal to 1. Okay, so there's that sort of funniness that's going on in math, and it's really interesting. And if you're into that, just keep taking math, and you'll beat it to death eventually, if you wish. Okay, you might get sick of it. Anyways, I think that'll do us for college algebra. Thank you for watching. If you watched all the videos, you deserve a certificate of some sort. I don't have a certificate, but if you ask me, maybe I can make one up. So anyways, thanks for watching. Thanks for being part of this, and we'll hopefully see you again. Okay, bye.